All right, as we get started today, go ahead and turn to page 25 in your speed drill and review exercise booklets, page 25, and we're going to do a 2-minute speed drill. Speed drill 24, a multiplication box. Go ahead and begin. Stop. Put your pencils down. Go ahead and put your pencils away, in fact, and take out a pen. Go ahead and put your pencils away and take out a pen. Check your answers as you go across each row. Top row going across, beginning with the 11. Your answers are 66, 110, 33, 79, 132, 77, 22, 121, 55, 44. Yes, ma'am.
The fourth one, it's 70?
99.
99. I can't read my own writing. That's a 9. Let's go with 99 on the fourth one across. I'm sorry. My 9, I didn't make the loop very big, and it looked like a 7. When you said it, I looked down, I was like, oh, that is a 9. It's hard to read from up here. All right, the row going across with the 7. Thank you. Row going across with the 7, 42. 70, 21, 63, 84, 49, 14, 77, 35, 28. The row beginning with the 4, 24, 40, 12, 36, 48, 28, 8, 44, 20, 16. And the row beginning with 12, 72, 120, 36, 108, 144, 84, 24, 132, 60, 48. And the bottom row going across, 36, 60, 18, 54, 72, 42, 12, 66, 30, 24. Were we both perfect? Good.
No.
Oh, which ones did you miss?
I just forgot 11 times 11.
121.
I put 111.
Ah, okay. All right, so 98 then, 2 points apiece. 2 points each. So figure the number wrong times 2, subtract from 100. So if you're like Josh and just missed 1, great job, 98. And then Lana, you said 100. All right, great job on that. We go and collect those from you. Take out your textbooks. Turn to page 493. Page 493. And for homework last night, you did numbers 11 through 20 in the homework section. Numbers 11 through 20. They're in the homework section on page 493. Page 493, 11 through 20. Good. All right, let's take a look at these together. Numbers 11 through 16, we're dividing by a monomial. And when we divide by a monomial, Lana, there are 3 steps.
Sign, number, letter.
Sign, number, letter. It's just important to remember that when you divide letters, you have to keep the winner wherever it is. So the biggest power remains in its starting position, whether that be numerator or denominator. So on the first one, Lana, sign, of course, is understood. The number is just 1. The R's are going to, but we're not going to cross them out because we're going to need that R for the next division. And then there's no friends for the T. What should I do with the T?
Leave it in the bottom.
Leave it in the denominator. Then we come back to sign, number, letter for a second time. The sign is?
Negative.
The number is?
3.
The R's again cancel. The T's this time cancel. And there's my answer, 1 over T minus 3. Josh, do you remember what we call an expression like this where part of it's a whole value, part of it's a fraction?
Is it a mixed expression?
Mixed expression, just like a mixed number would be part whole number, part fraction, mixed expression. Part fraction, part whole value. For the next one, we had a negative BC cubed, negative BC squared, all divided by a negative C squared. Joshua's sign? Numbers, of course, there are no numbers, so it would be a 1. Letters.
BC.
B stays in the top by itself, and then the C in the top wins.
Yeah.
Then sign.
Positive.
The B again has no friends.
Oh yeah, 1B.
And then the C squares this time will.
Cancel.
And there would be our answer. Nothing left in the denominators this time, so this would not be a mixed expression.
I like the ones, yeah.
Yeah, it would be not a problem at all to have your 1s written there, correct. Yep. Let's take a look at the next one. And number 13 works out evenly as well. Not a mixed expression for our answer, Lana. Number 13.
Positive 2j squared, positive 5j, positive 1.
Good. 2j squared, positive 5j, positive 11. Number 14, both divisions wind up with fractions. Let's see how you did here, Josh.
3y squared over 2x negative 2 over 3x squared.
3y squared over 2x minus 2 over 3x squared. Again, you can't divide 9 by 6, so reduce it to 3 over 2. You can't divide 4 by 6, reduce it to 2 over 3. Great job. Lana, number 15. Do we need to see that one worked out, Lana?
No, wait, so it was 3y squared over 2x, negative 2 over 3x squared?
Mm-hmm.
Oh, I just forgot to reduce the 9 and the 6.
So you had 9y squared over 6x.
Yeah.
Minus 2 over 3x squared. Okay? Number 15, Lana.
1c squared over 5, negative 1cd over 3, negative 1 over d.
Great job. C squared over 5, or 1c squared over 5, minus cd over 3, or 1cd over 3, minus 1 over d. Fantastic job. Joshua, did you get that?
I got everything except the last part. I forgot to keep the denominator.
So you just had minus 1 instead of 1 over d. Okay?
No, I had minus 1d.
Oh,
I
so
forgot
your
the
d actually moved up to the top by
Yeah.
accident. Instead of leaving him, he has no friends, leave him where he is. He's in the denominator. All right. Do we need to see that one worked out? All right. Number 16. What did you get, Joshua?
5 negative 1 over 2w negative 3 over 2w squared.
Yeah, that last division is really frustrating. It's like nothing, you can't do anything. Well, you just leave it then, right? So 5 works out nice. Minus 1 over 2w minus 3 over 2w squared is our answer. Lana, did you get that for 16?
I put 2 over w, negative 2 over.
On the second part? Let's take a look at it really quickly. I know we haven't worked the last couple, so it's probably good to work one on the board just for sake of demonstrating for our viewing audience. Hi, Scott. And so when we divide here, sign, number, letter, sign positive, number 5, and the w squareds cancel. Here's where the question was, right in the middle. So we have a negative divided by positive is negative. 1 divided by 2, you can't do that, so we just leave a half. A 4 over 2 would be 2. But 1 over 2 is just a half. Does that make sense? and then the W cancels with one of these, but you still have a W in the bottom.
I thought it was 2 divided by 1. You put it in the top.
It's not 2 divided by 1, it's 1 divided by 2. This is 10 divided by 2. This is 1 divided by 2. This is 3 divided by 2. Does that make sense? And then of course here the last part, 3 doesn't divide by 2, so we leave the 3 halves. The W squared has no friends, we leave the W squared. It's kind of an unsatisfactory end to our division problem, but this is what we should have had there. Questions on that? All right, we'll work on more of those here in just a little bit, I believe. Yes, here shortly. Let's take a look at GCF and LCM. Remember, greatest common factor, you're looking for what is actually shared by the two numbers. For least common multiple, we're going to have a contest and see who wins. So for 16 and 20, it's number 17. The number 16 and the number 20, what's the greatest common factor, Lana? 4 is the greatest common factor. They both have 2 2's in their factor list. But what's the least common multiple? 80. The 4 2's from the 16 beat the 2 from the 20, but the 5 from the 20 wins by default, so we have to include that winner, so we end up with 80. Did we get that for number 17? Number 18, you had 30 and 33. The GCF, first of all, is just 3, but the LCM is 330. Excellent. Got to keep the 11. There's a tie for the 3, and the 2 and the 5 are default winners as well, so they all have to get multiplied. Number 19, 45, 90, 120. What's the GCF, Lana?
15.
15 is correct. Great job. They both have a 3 and a 5. And then what's that LCM?
360.
360. Great job. Both of you got that. Then 21, 35, 42. The GCF is, Joshua? 7. Pretty straightforward there. The only thing that's shared by those numbers. And the least common multiple? 210. Excellent. Tell you what, for YouTube audience, in case there were questions, I want to go ahead and show number 19 very quickly. We had 45, we had 90, we had 120. And again, the key here is the common factoring, or the prime factoring. So we prime factor the 45, 3 times 15, which becomes 3 times 5. 90 is 2 times 45, which becomes 3 times 15, which becomes 3 times 5. Then 120 is 2 times 60, which becomes 2 times 30, which becomes 2 times 15, which becomes 3 times 5. Of course, you could do division of primes, you could use a factoring tree, do it however you want. But once you have the prime factors, which I assume at this point we know how to prime factor, they all have at least 1 3, but no more. Like these two have 2 3's, but this one doesn't have another 3. These both have a 2, but this one doesn't have a 2. But they do all have a 3, and they all have a 5. There's the 3 times 5, greatest common factor, 15. When it comes to finding the least common multiple, remember, there's your winner of the 2's. That's a loser. Either this or this is a winner of the 3's. Let's just pick this one and call this one a loser. And that's a loser too. And any one of the 5's, let's just give everyone a chance to win something. You know, everybody gets a trophy. And this will be our winner of the 5's, and we'll call both of these losers. So that's where Lana had the 2 times 2 times 2, times 3 times 3, times 5 to get 360 for the LCM. All right, questions on this? All right, turn over to page 498 now. Page 498. And I want you to do numbers 32 to 37. They're in the review section, practicing with evaluation. And then we'll get back into the other algebra we've been working on, but a little bit of practice here. Page 498 in the review, 32 to 37, practicing with some numerical substitution or evaluation. Be sure to follow order of operations once you plug in the values. This is your longest streak yet, Lana. You're at 8 perfect speed drills in a row. Josh is like, show off. I'm just kidding. Josh is not hateful. Scott might be making noises on the other side of the camera, but Josh is a good kid. We only have 3 speed drills the rest of the year. 3, that's it. Almost done. Hayden's like, do I only have 3? No, you probably have like 10 left. But
No, we don't have to ever do Last time I looked, yeah, they have all 10 We've only done 2 every year.
all right, let's go ahead and take a look at 32 to 37 together. Number 32, Lana. 18, 33.
Negative 160.
On 33?
What?
Oh, I know what you did. You treated it like it was all multiplication. What we have is a 2x minus a 5x, and x is equal to negative 4. Now, technically, Joshua, what we could do is we could combine like terms up front. What is 2x negative 5x?
Negative 7x.
Subtract, keep the sign of the greater,
right,
negative 3x, which means negative 3 times negative 4, which equals
Positive 12.
positive 12. That's the answer we should have gotten. But even if you plugged in the negative 4 here, this becomes negative 8. This becomes positive 20. But again, they're separate terms. You're not multiplying to get negative 160. You're taking a negative 8 and a positive 20 and adding them or combining them to get the positive 12. You multiplied your negative 8 and positive 20. Does that make sense? Or you might have possibly multiplied to get negative 10x squared. But again, it's addition, it's combining, it's not multiplication. For redemption, Joshua, number 34. 18. Number 35, Lana.
Negative 2.
Negative 2. Number 36, Joshua.
I got 0 over 12.
0 over 12, which equals?
12.
0 divided by 12 equals 0. And they're all holding up 0. 0 divided by anything is 0. You can't divide by a 0, but 0 divided by anything equals 0. And number 37, Lana.
Positive 4.
Positive 4. Lana, did you get them all right?
Mm-hmm.
And then Josh, we didn't simplify the 0 over 12 down to a 0, and of course we had some struggles on 33. Did you get the others correct? All right, any questions on those? All right, turn back to page 494. Page 494, and let's work on here some multiplication and some division. I want you to do numbers 1 through 11, the odd. Page 494, doing just 1 through 11, the odd. Practicing with distribution. Sign, number, letter as you distribute. And then sign, number, letter again. And then sometimes sign, number, letter again. So words just resonate in your mind. You wake up, sign, number, letter. Sign, number, letter. Lana's like, Lana's mom's like, Lana, honey, wake up, wake up. Sign, number, letter. Sign, number, letter. You're having a nightmare, dear. It's not math class. Wake up. It's like, oh, Mom, there was this monomial being multiplied by this 12-term polynomial. It was so long. It's all over now, honey. It's breakfast time. Ah. It's a happy ending to the movie. All right. Because she finds out she's not really in math class. But now, bum, 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 you are in math class. And now it is time for sign number letter. Does your mom wake you up or do you have an alarm clock?
She wakes us up.
Really?
Mhm.
I have it on the alarm.
If we had an alarm, I just hit it and go back to sleep.
Same here. When we first started school, my mom was like, "Set your alarm." I was like, "Yeah, that's for you," because when she comes in there and wakes me up at 6, I don't get up till 6:45.
See, if I hit the alarm clock, my parents would come in and hit me. So I would learn not to hit the alarm clock. I'd learn to get out of bed.
Well, if
Because
they
I had parents who
train
taught me,
to-
you know, responsibility. But
well,
anyway, I
if
did.
they train you
I'm just
to-
kidding.
if they train you to get up. Well, not training, but
Yeah, that's the right word for
they
it.
taught me how to get up with my alarm clock. And
You would.
Yeah, I would,
You
but
would.
they just always.
Besides, think of all the fun things you can do to your kid when you wake them up. All kinds of stupid, mean things one can do to one's children.
Oh, my dad one time came in there and dumped water on my head.
See? Stuff like that. Our youth pastor one time borrowed, we went to camp, and there was this guy who had played the tuba. And so the youth pastor borrowed his tuba and went right over the bunk of this one kid in the corner who was sleeping in, not getting up like he was supposed to, as blew as hard as he could into that tuba.
Oh.
The guy's body literally rose out of the bed and went back down. I've never seen anything like it. It was so funny.
Oh.
Unfortunately, I don't have a tuba, so I can't do that to my kid. And a
Yeah.
violin just wouldn't have the same effect.
You
So.
need to have
I was too busy
something.
talking.
Yeah, like Jaden when they like
Rights and
when Mr. McDonald be teaching and like just holler out in the middle of nowhere, I'm serious she'll come this far off of her chair. Like the other day when they called somebody on the intercom, Jaden, it was in Bible class, and she literally shut up. I was like,
Wait,
something that ain't right.
why does it have a 130?
A 130.
a 130.
130.
Well, 1/3. Oh, because that's what you're multiplying is a 1/3. Don't overthink it. Think of for multiply. A third of means times. So a third of 3, a third of 6, a third of 9.
All I think about when I'm in bed and I wake up is can I go back to sleep?
I can't because I just go back to sleep.
Tell you what, for sake of time, since I distracted Lana so she couldn't finish, let's see what she did get finished here. Number 1, Lana, what did you get when you distributed the 8?
8r squared negative 8r.
Good, 8r squared negative 8r. Number 3, Josh, you distributed negative 7.
Negative 14s positive 21t.
Good, negative 14s positive 21t. Number 5, Lana.
Negative 9qr positive 5q.
Good, negative 9qr positive 5q. Number 7, you were distributing a 5b. Actually, let me stay with Lana here.
50b cubed negative 10b.
Good, 50b cubed negative 10b. Now we come Joshua, number 9. I think this is the one Lana was working on. Sign number letter, and you're multiplying a 1/3 as your number. What did you get for your answer?
1d cubed positive 2d squared positive 3d.
Excellent. A third of 3 is 1, and d times d squared is d cubed. A third of 6 is 2, and d times d is d squared. A third of 9 is 3, and d times, well, nothing else is just d. So d cubed positive 2d squared positive 3d. Great job, Joshua. And then number 11, Joshua again.
J to the 5th k cubed positive j to the 4th k to the 4th negative j to the 4th k.
Excellent. J to the 5th k cubed positive j to the 4th k to the 4th negative j to the 4th k. Excellent job. Questions on those? Question, Lana.
I don't think I. Wait, I think I got that one.
Do you need me to repeat an answer?
Yes.
Which one? Number 11?
Yeah.
J to the 5th, k cubed, positive j to the 4th, k to the 4th, negative j to the 4th, k.
Oh, negative.
sign, number, letter. All right, questions on those? Now let's practice with the double distribution or FOIL as we do 13 to 23, the odd. 13 to 23, the odd. Let's review over the FOIL or the double distribution. As you finish, check your answers. Number 13, 15, 17, 19, 21, and 23. Check every sign, every number, every letter. Good to go. Perfect on all 6. Great job, Joshua.
I made one tiny mistake.
All right, what was your one mistake?
I just forgot to add.
On.
Well, I had 6x squared positive 1 negative 1.
Okay. When you correctly added to get 1x, you just forgot to actually write the x.
Wait. Oh yeah, yeah. That's I just forgot.
All right, any questions on those?
No.
Was that your pencil again?
What?
I thought I heard another pencil drop.
It wasn't mine.
That was Glenn. Okay. All right. I was like, how did she drop a pencil again? She just picked it up. It wasn't you. It was just over there. Write this down on a piece of paper if you would, or maybe at the bottom of the page, there's a little bit of empty space there at the bottom. Write down this, 3x minus 4 times m plus 2n. We're going to double distribute on this just like we would anything else, but you're going to notice because these binomials look so different from each other, you're not going to get that outer inner combining. There won't be any like terms, but we still double distribute. We distribute here, Joshua, sign, number, letter to get.
Positive 3 and
Good job putting it alphabetically. We distribute here, Lana, to get.
Positive 6 and x.
And then we switch to the negative 4. We distribute Josh to get.
negative 4a.
And we finally finish the distribution, Lana, by getting
Negative 8n.
negative 8n. And nothing combines. There are no like terms because these were dissimilar binomials, but the process didn't change, right? Same process we always would use. Write this down then. R positive 3s, and let's multiply that by AB negative 5c. Go ahead and double distribute or FOIL those two binomials together. 7th grade, you're dismissed. And it looks kind of ugly. But there it is. Check your answer against the board.
Brenda.
Oh, okay, yeah. Well,
I got it.
Good to go.
how is it negative 5 CR?
Right here, when you distribute, it's a positive 1r times a negative 5c. Sign negative number 5. Letter is RC, but we want to put them alphabetically, so CR.
I just missed the 5 part. I didn't move there.
All right. Homework for this evening is to do pages 494 to 495, pages 494 to 495, 2 through 32, the even. Pages 494 to 495, numbers 2 through 32, the even. We'll take a look at that tomorrow as we wrap up this section on multiplying and dividing monomials and polynomials. All right, you are dismissed.